In this video, we will discuss the importance of airlifting and 2 ways that air is lifted. We'll also go over weather fronts, and then we'll discuss the formation of precipitation and the differences between rain, snow, sleet, and hail. So why is airlifting important? Well, it's important because airlifting is needed for the formation of clouds and rain. Most clouds form when air cools to the dew point. The dew point is just the temperature at which the air has cooled enough to reach saturation as the parcel of air rises vertically. 2 of these 3 mechanisms that form clouds are orographic lifting and frontal wedging. Orographic lifting is when air is forced to rise over a mountainous barrier. So as the air rises up the mountain, it is allowed to expand. Therefore, it cools adiabatically. Water vapor is then allowed to condense, and this creates clouds, and under the right conditions, precipitation. Frontal wedging is the reason why we don't have to depend on only mountainous regions to lift air. Frontal wedging occurs when warmer, less dense air is forced to rise over cooler, denser air as a weather front moves. So, when large masses of warm air and cold air meet, they do not mix. Instead, they form a front. We're going to go over the 4 types of fronts. So, a cold front forms when cold air mass pushes under a warm one, which forces the warm air to rise. When this happens, you can expect a lot of thunderstorms. A warm front forms when a moist, warm air slides up under and over a cold one. So, since this warm air mass rises, it condenses into clouds. So this will usually bring snow, gentle rain, and then some milder weather after. A stationary front forms when cold and warm air meet and neither has the force to move one another, so they just stand still. When the warm and cold air meet, clouds and fog form and it may rain or snow. It can also bring clouds and precipitation. An occluded front. So this forms when a warm air mass gets caught in between 2 cold ones. And so the warm air has to rise as the cool air masses push and meet in the middle. It's going up and in. The temperature drops as the warm air mass is cut off from the ground and pushed upward. So this usually means strong winds and rain, precipitation. So what happens when those clouds reach that saturation point? Well, we're going to have precipitation, and precipitation is any liquid or solid water particles that fall from the atmosphere and they reach the ground. Now, precipitation is not formed through growth by condensation because it would take a very long time to form a full-size raindrop this way. So we have the collision-collations process. And that means very small particles bump into each other, they merge together, and eventually they spill out. That's going to do with rain. However, rain, snow, sleet, and hail are all different types of precipitation and are formed in different ways. So, the way that these water vapor particles make their way down to the earth defines whether they will be called rain, snow, sleet, or hail. So as we were talking about earlier, the droplets are forming together in the collision-coalescence process. In rain, those droplets will eventually become too big. They will either leave as liquid or leave as ice crystals, but eventually they will hit the ground as liquid water. When snow is formed, those particles build up together. They will leave as ice crystals and they will fall all the way down as ice crystals, which will give you snow. When sleet occurs, it's because those particles build up together, leave as snow, then they'll freeze. They will melt and then refreeze again before reaching the surface. So with hail, those droplets are caught up in the cloud. They'll go up and down, they'll freeze and unfreeze and refreeze. They'll form hailstones, and as the more water droplets freeze onto them, they'll eventually get too heavy and fall to the ground. Alrighty, and that's all I have for now. Hope you enjoyed learning about everything. Like, comment, subscribe.